So welcome to the lecture on automatic control. Today is the first lecture and we will discuss in this lecture the first module, that is automatic control system, and we will in this first lecture we will discuss the definition of the control system and the types of the control system. So automatic control is used in many applications from aerospace, automobiles, manufacturing sectors, robotics, and others. So what does it mean automatic? Automatic means that we are going to get certain output performance of the system for different inputs. So we are able to maintain the performance of the system even though the input is varying or we are giving some specific input, because there are some disturbances that comes in the system from environment, and therefore we need a control system, and therefore this subject is very important to mechanical engineers, electrical engineers, electronics engineers, and similar subjects. So now we start to understand what is a control system. Let's understand what is a system. So a system is a collection of components which are coordinated together to perform certain function. So if we want to draw a system, a general system, so suppose this is a system. So why we call it system? Because it is some region that is separated from the surroundings or environment. So here is surrounding or environment, and this is boundary. So this system and environment, there is interaction through the boundary. So there could be some inputs to the system from the surrounding, and then system will give some output as a response of that input. So there is some output. It is possible that there could be several inputs to the system and there could be multiple outputs from the system. Now inside the system there are several components. We call it subsystems. So let's say there is some subsystem. This is subsystem 1 and this is 2, and each subsystem has certain input and then it gives some output. So therefore when we define a system, we say that it is assemblage of or collection of several components, and they are coordinated such that they give certain output, they perform certain function. Now from this environment there could be entering certain disturbance input, means the input that we don't want, and that may enter into the system. For example, if we want to listen some music, there could be some outside noise that is entering to the room and we can't listen properly that music. So that noise that is coming from outside, from the environment, that is the disturbance input. So this is our system, and that gets disturbance input from the environment. So a system is basically represented like it gets some input and it gives some output. So therefore the interaction is defined from input and output and environmental disturbances. Now we try to understand what is a control system, because we understand this is the definition of a general system. Now what is a control system? So a control system is defined, again it is assemblage of or collection of subsystems and processes, and the purpose is to obtain a desired output with desired performance given a specific input. These 3 points we must understand in detail, that what is desired output and desired performance and specific input. So in any system, the mechanical system or electrical system, we try to give specific input, means we know that we are going to give the input and system should give certain output. So that is desired output. We expect some output from the system, not any output, but some desired that we want with desired performance. Performance of a system is the specifications of the output, means whether this is giving output, but with what degree of accuracy, with how much it satisfied the user. So this is the desired performance and specific input. Input is in our hand, we are going to give input. But what happens, we are going to give certain input to get some desired output, but we saw that for any system that can interact with the surrounding or environment and it can get some disturbance input. So due to this disturbance input, the system will not be able to give the desired output, because now input, if it is purely the input that we are giving, that is specific input, it is made to give the desired output. But if there is some disturbance input also, the system will give some output that is different from the desired output. And therefore we need a control system. So therefore what is the definition of control system? That if we give a specific input, that system should give the desired output with desired performance. So this we can understand here from this diagram. Here is input or desired response. Many times the input is the same as desired response. For example, the elevator. If we want to go on the 4th floor, we will press the button 4. And so here input is 4 and our desired output is 4. So therefore, many times input is the same as the desired response. We can see here an elevator. So suppose this is time, an elevator, let's say we are at the ground floor and we want to go at 4th floor. So we give some input command 4. This is input. We press the button 4, number 4, so that the lift can or elevator can take us to that floor. Now the elevator, from time t equal to 0, we press the button, it will take some time to reach at this floor, and its response will be something like this. Now, you can see from this diagram here that this initial part of the response is transient response. Transient response means it is a time varying response. Here it is varied with time. After this point, it is going to be constant, and this is called steady state response. Now, this difference between the two, so this is the output, this is output, and so there is a difference between the two, that is steady state error So this is a steady state error, this difference between input and the output of the system, steady state output. Now we should understand that this elevator, if this transient response is very fast, so what will happen? The elevator will start and to move very quickly, and very fast response can make discomfortable to the people who are in the lift. Suppose this transient response is very slow, means it takes much time to reach to the steady state response. So it means you have to wait for long time, and so your patience, you have to be more patience of the people, so more waiting time. Now what about this steady state? We see that we desired to fourth floor, but it is not reaching, it is little bit lower than that floor. It means the lift is not labeled to the floor, it is little lower. So this will govern the safety of the people, because if it is lower you have to jump out to go out from the lift, and so it could be even unsafe to the people. So we can understand that when a control system, we have a specific input, and this is the desired output, but now there is certain difference between the input and output. So therefore the question or these topics is more important, that we should learn how to design a proper system that can give a transient response that is comfortable to the passengers or the people in the lift. At the same time, it doesn't give more waiting time, and secondly, it reaches to as close to as to the input, that is to the level of the floor, so that people are safe. And that's why we should try to learn the design and analysis of control system. Now we try to discuss the type of the control system. So there are basically two types of control systems: open loop system and closed loop system. So what is open loop system? So what we are seeing here in this slide, this figure, that is the open loop system. Open loop system is, there is no any feedback to the system. So we can see here, we are giving input, and there is some input transducer in the system. Then there is controller. here is some summing junction, then this is the process or plant, then again there is summing junction, and then there is the output. Now we can see that we give certain input, and what is the role of input transducer? So input transducer converts a signal, the input that we give, it converts to a signal, maybe electrical signal, that is accepted by the controller. So if we press number 4 and our controller is going to read the voltage, this transducer will convert this number 4 to the corresponding voltage in, and that voltage will be input to the controller. Now here we can see that here is the process or plant. So process is, if we see the example of elevator, the lift is the process or plant. This is the plant that we want to control. So, but there could be enter a disturbance input when the controller is going to control this process, giving some input to the process. The input to the process can be corrupted by some disturbance, one that is entering from the environment, and therefore the actual input that is going to the process or plant is different than what was given at the beginning of this system. Now second thing, when process will give some output, but the output that we will get actually can be mixed with some disturbance from the environment, and the actual output will be again different. So there is two level of corruption of the signals here, and at the input of the processor plant, and second at the output of the processor plant, and therefore there is risk of not getting the output, that desired output. And therefore we see that open control systems, there is no any facility to monitor that how much the output is different from the expected, okay, and how to counter the disturbances that are entering to the summing junctions or to the input and output of the process or plant. So these systems cannot compensate for disturbances. So examples, if we take examples, there could be the simple toaster, like we put the breads and we set maybe some time. Now it doesn't give the input that whether the bread is already burnt. If you set that time, it will, after that time you will get what it remains. But, and then there is washing machines, you set the time, they don't sense whether the inside conditions, but they will do the functions at that what is defined at that time. Fan, we switch on the fan and fan will start. It doesn't matter, doesn't take any input from whether the fan's speed is actually as expected or not. Some fans are, you press button number 4 and some fans are very fast, some fans are very at slow speed. So we are not going to take the input as a feedback, okay, or we are not going to monitor that whether what we pressed, are we getting the same or not. So these are the open loop systems, and the disadvantage of this open loop system is that they are not going to monitor the output, and they have no any mechanism to counter the disturbances that are entering to the system from the environment. So now we come to the more sophisticated system, that is a closed loop system. So in contrary to open loop system, they can monitor the output and they can compare the output to the input. Now we can see here in this figure, here is the input, we are giving to the input is going to the input transducer. This transducer will convert the input to a signal that is accepted by the controller. Then this controller will give certain output to actuate the process or plant, and there is disturbance 1 entering to these summing junctions. It is corrupting the input to the process or plant. Then there is output, and this disturbance 2 enters to this junction and it will corrupt the output. Now what this closed loop system is going to handle this problem is it takes the output as a feedback to the input. So we are taking back the output. We want to know what are we getting actually the output that we expect? Means are we going to get the desired output or not? That's why we are taking back this output, feeding back to the input. So this output we are taking. There is another transducer, that is output transducer or sensor. So this is going to convert again this output signal to a corresponding signal, that is maybe electrical signal, that is accepted to the controller. So here at the summing junction there is input coming from input transducer, and there is the output going from output transducer, and here input and output they are compared, means the difference between the input and output is calculated here and given to the controller. So we are going to get that how much difference is there between input and output, and only that difference is given to the controller, and controller will give only that much signal to run the process or plant. This loop will be working, or the controller will be working, or plant will be working till this difference between input and output will be equal to 0. And this will be the moment when we can say that we have achieved the desired output, and therefore this system is monitoring the output and comparing to the input, and if there is some error it corrects the output, and therefore it has the mechanism to counter the disturbances coming from the environment. And therefore automatic control system should have this feature, that should be based on the feedback control system or closed loop control system. Automatic control system cannot be based on open loop system. The examples are air conditioner or microwave oven. There can be other numerous examples. So air conditioner, we set some temperature, and it is, if the difference in the temperature, actual temperature and the set temperature is more, the compressor will run faster, and as we get closer it will be, when we reach to the same temperature it will stop. And so it continuously takes the feedback whether it has reached to that temperature or not. It measures the room temperature and compares to the output. So air conditioner is a closed loop system. The complex toaster that measures the color of the food material inside the toaster, they are also a sophisticated control system, closed loop system, because they not only based on the time, but they are based on the color of the food, and therefore they could be also a closed loop system. So now if we want to enlist the differences between an open loop and closed loop system. So we can compare. So open loop system has several disadvantages but few advantages, and vice versa to the closed loop system. So the open loop system, they are incapable to respond against the disturbances that are entering to the system from the environment. They don't measure the disturbances, or they don't correct the disturbances, and they are simply commanded by the input. Once we give the input command, they will give certain output, and that output might be different from the desired output, because there will be certain disturbances entering from the environment and they don't compensate, they don't take care of these disturbances. While in contrary, closed loop systems, they monitor the output and they compare it to the input by giving a feedback loop. They give a feedback from output to the input, and they compare this output and input, and they find the error, give to the controller, and they will be acting till the error is 0, means till we get the desired output what we expected. So therefore this closed loop system has advantage over open loop. Now this closed loop system has greater accuracy. They are more accurate. They give this input and output difference is very less. They are almost reaching to the same input command as we are giving here. So this steady state error is very less. So we are more accurate to the output. In contrary, the open loop systems have a very poor accuracy. Closed loop systems are less sensitive to the noise or disturbances from the environment or change in the temperature from the environment. Why? Because these are the disturbances that are coming from the environment, and these systems have mechanism inside to counter these disturbances, whether it is noise or temperature disturbance or any other vibration disturbance depending on the system. They have the mechanism to counter these disturbances, so they don't let the system's performance get down due to these disturbances. So we can say that they are less sensitive to these disturbances. While contrary to this, the open loop systems are very much sensitive to the disturbances. If the disturbances are more, the systems, open loop systems performance will be affected very much, and they will lose the actual desired output, and steady state error might be increasing. So therefore these open loop systems can be said that they are very sensitive to the disturbances. Now, what are the advantages of the open loop systems? One thing is simplicity. They don't have any feedback system. They are simple forward loop systems. So they are simple systems. And if you have a simple system, it is less expensive. It is less costly. So these systems are simple and less expensive. While if we compare to the closed loop systems, these systems are because they have greater accuracy, they have more sophisticated control system, and therefore they are more expensive and more complex. So these are the some common differences between the two systems, open loop and closed loop. So here we follow mainly the two reference books, one Norman S. Nice Control Systems Engineering, and second K. Ogata Modern Control Engineering. So these two books we will follow in this subject, and several examples will be taken from these books. So here now I thank you for this lecture, listening this lecture, and let's see in the next lecture. Thanks.